All right. How is everyone? I'm here in Shanghai at the moment. It's about 7:30, so I would say good evening, but I know that's not the case. I believe it is good afternoon for you because you might be right after lunch at this point. So hopefully I didn't lose too many folks. I'm going to start sharing my screen soon, but before I do that, just a brief introduction from my part. My name is Reza Rahman, and my day job, I'm Principal Program Manager for Java on Azure at Microsoft. And as some of you may be aware, Microsoft is part of the Jakarta working group. And in fact, I'll be talking a little bit about today. The talk is about taking a small part of Azure, which is Azure Cosmos DB, and I'll explain what that is, and marrying it up with a very interesting technology out of the Jakarta working group named Jakarta NoSQL. So without further ado, I'm going to start sharing my screen and we can get rolling. So here we go. I'm going to share my whole screen and let's get rolling. So I'm going to lower and hide. Hopefully you can see my screen okay. All right, so most of this talk is really not going to be a whole lot of slides. I do have a small number of slides, and the slides are available on Speaker Deck. I'll share the link with it a bit later. But certainly if you go onto my Speaker Deck account right now, you'll be able to see the slide deck. I'm going to do just a little bit of slideware, not too much, but primarily we're going to be jumping into looking at actual code very quickly. But let's do a brief introduction in the interim. So here we go. All right, so as we talked about, this is sort of a mashup talk. So one of the key parts is going to be Jakarta NoSQL, and the other part is going to be Cosmos DB. So I'm going to introduce both concepts with you really quickly. So first and foremost, let's talk about Jakarta NoSQL. What is it? For those of you who are not aware, Jakarta EE, the Jakarta EE umbrella, is basically the new name for the technology that is formerly known as Java EE. So it's a set of specifications, and the Jakarta NoSQL is a specification, similarly a specification. It is currently not included in the Jakarta EE umbrella specification, but it is a standalone specification that you can use on your own in Jakarta EE applications, or perhaps even outside of Jakarta EE applications, because actually it's a quite a well designed technology and a well designed specification. So as the name suggests, basically what Jakarta NoSQL does is that it is a set of APIs for accessing NoSQL databases in a uniform way. In other words, if you will, to use a cliche, one API to rule them all. Use a single technology, single API to access multiple kinds of NoSQL databases with whatever the gamut of NoSQL databases are, which we'll talk about also in a moment. If you're familiar with Jakarta Persistence or JPA, Jakarta NoSQL will feel terribly familiar. So really, the set of APIs are very similar to what you would see in JPA or Jakarta Persistence. It consists of a set of mapping annotations that describe how to map a particular Java object into a database, and a template API similar to the Entity Manager API in Jakarta Persistence. It's very similar to that. So it's a templating API, if you will, that allows you to do simple things like CRUD operations plus some queries. Now, the interesting part you should ask yourself is like, how do you go about creating one API that rules all when you have such a large diversity of NoSQL databases out there? And Jakarta NoSQL really does this in a relatively clever way. So what it does is that it recognizes that there are taxonomies or categories of different NoSQL databases. And basically, it provides a slightly different API, particularly at the template API level, not so much with the annotations, but the template API level, that targets a particular class of NoSQL databases. So this is how you can actually have an API that covers such a broad range of the NoSQL ecosystem. So the taxonomies hopefully is pretty familiar to you if you're familiar with NoSQL. So these are key value pairs. So this is the type of database where you have a key, and it could be a compound complex key, and there's a value. The value is typically either simply a blob or some kind of JSON format, but the database doesn't get in the business of understanding that format. It simply says, hey, if you have a key, here's its value, and It's up to you to figure out, what you do with that value. So that's the key value pair of NoSQL databases, and it's the simplest type of NoSQL database. The other one is column family, and this is another interesting one, because what this does is that it is very similar to key value pair in a sense, right? In other words, there is a key and a value, but the value is actually understood to be not one unitary value, but essentially a record, or a row in a table. So in other words, a set of columns that the database recognizes, and you can possibly query the database with those columns. So a key could be whatever, let's say, social security number in the United States. And the column could be essentially a record that says, okay, this is the name of the person, last name of the person, first name of the person, their address, phone number, so on. So and those are recognized to be distinct columns in the value part of the database. Again, it's somewhat popular. I'll talk a little bit about what a column family database is. A key value pair database, a good example of that is Redis, for example. That's a key value pair database. Column family databases are somewhat popular. So Cassandra is a good example of a column family database. A step up from that is a document database. So a document database, again, is about key values, but the values are not only columns, but rather structures themselves. So they are recognized to be documents. So essentially think about JSON, and typically it is the value part in this type of NoSQL database really is stored in many cases in something like JSON. So it is a structured object, right? So it has it may even have nested objects within it. That's why it's called a document database. And in fact, this is the most popular type of NoSQL database, and MongoDB, which is the most popular NoSQL database, I'll show you proof of that in a moment, happens to be a document type database. Now, there's a fourth type of NoSQL database out there. It's called a graph database, and graphs are interesting in the sense that it isn't really key value. It's really a set of graphs that are a set of objects stored in a database that have some kind of interrelationship. It could be one-to-one, one-to-many, many-to-many, so on. And each of the nodes are objects, essentially. Right? So this type of database is not terribly popular. Neo4j is an example of it. And they're used in applications that the data maps well to a graph format. So think about perhaps LinkedIn would be a good candidate for something like a graph database. Now, Jakarta NoSQL actually integrates with a number of other Jakarta specifications. And in no particular order, these are these. So first is Jakarta Data. And I'll talk about Jakarta Data in a moment when we talk a little bit about the repositories and template APIs. So basically, Jakarta Data is something very similar to Spring Data JPA, or if you're familiar more with Delta Spike Data, it's that. So it takes the template portion of the API, and it creates an even higher level of abstraction over it that is simply an annotated interface, right? And then basically all of the rest of the stuff is generated for you. So Jakarta NoSQL does integrate with Jakarta Data. So if you don't want to use an entity manager style API, you can use a higher level API if you wanted to. The other one Jakarta NoSQL integrates with, and I'll show you in the demo, is the Bean-Val, or not Bean-Validation. These days it's simply called Jakarta Validation APIs. So what this does is that via annotations, you can say, hey, this particular field should follow this particular rules or rule validation rules. Lastly, the Jakarta NoSQL also integrates with the configuration API in MicroProfile. And this sort of makes configuring Jakarta NoSQL very, very simple. And again, I'll show you an example of that in the example application. So last thing you should know is that Jakarta NoSQL is has had its first stable release, but that doesn't mean you shouldn't use it, right? Because there's actually quite a few people using Jakarta NoSQL already, although it's just a beta release. And in fact, I've used it myself. It's pretty stable. It's a nice API to work with, but the stable release should be coming very soon. I would say, probably within the next few months, if you need to use something that is absolutely stable. If you have the kind of environment, kind of company that absolutely has to have a release version of something. Okay. The last thing I want to mention is don't hold questions until the very end. Feel free to ask your questions throughout. I'm going to intermittently stop and pause and basically check the chat. Feel free to post your questions in the chat, and then I will answer them in real time. So there's no reason why we need to, hold until the very end for questions. We can do questions throughout. So next, let's talk a little bit about how many databases does Jakarta NoSQL cover? So Jakarta NoSQL, as you know, is a standard. It does have a single implementation at this point. It's called JNoSQL. And JNoSQL actually supports, in my opinion, the broadest range of NoSQL databases out there that any single technology can support. So as you can see, a whole bunch of NoSQL databases can be supported. I'm going to focus today on Azure Cosmos DB, but if you want to use any other NoSQL database, you can very easily do that through Jakarta NoSQL. It really is really that good. So whatever your NoSQL database is, I suspect you will find support for it in the main implementation of Jakarta NoSQL, which is JNoSQL. All right, so let's move forward. So one of the things that, if we talk about NoSQL databases, one thing we ought to understand is what is the use case and how popular really are these NoSQL databases to begin with. So I remember a time when, sort of everybody was saying, oh, NoSQL databases are just going to replace all of the relational databases, and it will become, the only way or the canonical way where we store data. Now, obviously, this type of statement and mentality was about 10 years ago. What has happened since is really the NoSQL ecosystem has stabilized, right? So you can see that in this graph. This graph is roughly from 2010 when NoSQL first emerged until now, and you can see there is some early growth, but really it is leveled out. I would say around 2015 or so, right? 2015, 2016. And things have really been on even keel. So this is not, it hasn't taken over anything. It isn't like exponentially growing. But I would say this is a technology that essentially has found its niche. It's found a place, a useful and meaningful place for itself. And we'll talk about in a moment what that useful place is. The other thing you'll notice is that there are very clear winners and losers in this NoSQL landscape. Although there's a whole bunch of NoSQL databases, really the main ones are a limited subset. Okay, so as you can see in this graphic, I put in probably the 5 most popular ones in terms of NoSQL databases, and you can see a very clear pattern. So by far, the most popular NoSQL database ever, right, is MongoDB, and it's by a good margin, right? So it's a relatively large margin. It is very clearly the leader. Literally, if you were to say NoSQL is synonymous with MongoDB, you wouldn't be entirely wrong in holding that opinion. The next popular one is Redis. Redis is an interesting one because it's not necessarily just a NoSQL database. You can simply consider it a distributed cache. So the fact that Redis is the second most popular is a very clear indicator, really, just how much the NoSQL ecosystem is dominated by MongoDB. And all the rest, right? I could have put in several dozen of them. They really belong at a much lower levels of adoption. So this is important information for you to understand, when you are considering this NoSQL landscape. Now, let's take a moment and basically try to compare this with how things look like in general, right? So there's a nice website out there. It's called DB Engines Ranking. And just like we have the TOB programming language index, this basically is an index. It's a popularity index that tries to figure out, okay, how popular are each of these databases? And they mix both NoSQL databases with relational databases. So you can really see a very clear picture of what precisely is happening. And the picture is, in fact, very, very clear. So as you can see, at the top level, really the most dominant databases that have remained for a very long time, throughout the NoSQL hype cycle, really has been relational databases. So the top ones are Oracle, MySQL, SQL Server, PostgreSQL, and then at the very end, right? So you can see those top leaders; those are all relational databases, and then right under there is MongoDB somewhere, right? And under there is Redis somewhere. So this is essentially it is not going to ever be replacing these relational databases at this point. I think it's fairly clear. After such a long period of time, it would have it would if that would have happened. So that is not happening, right? So the question is, what is happening, right? And when should you really consider these NoSQL databases? So I'll share some anecdotes with you within our customer base, because we have a NoSQL NoSQL solution at Microsoft. It's called Azure Cosmos DB. So typically, there's in most applications, you would be best served if you actually started with relational databases, and that is true for a vast majority of applications, probably good 80% or more. Now, the main couple of reasons why you would want to use a NoSQL database really is about scale. So anything above, like say a gigabyte, multiple gigabytes of data, frankly, relational databases can easily handle those. But when you're talking about multiple terabytes of data, right? That's a lot of data. That's a amount of data that a single relational database cluster will not be able to handle. So that is a case where you really should be considering a NoSQL database. Another one is if you need near real-time access to a single data source across multiple distributed geographies. Okay, that is another use case for using NoSQL databases, because the relational databases just don't scale that way across geographies. So that's another case for using something like a MongoDB, if you will. And each case is if you have really unstructured data, right? So, data that just doesn't make sense to put into a relational database. That's another case, a separate and legitimate case for using NoSQL. So now let's talk a little bit about Azure Cosmos DB and what it is. Okay. Actually, before I jump into that, let me just quickly check to see if there are any questions in the chat that I should answer. All right. I don't see any questions yet, so don't be shy, right? If you have questions, go ahead and ask them right away. You don't need to wait until the very end. I'm happy to sort of answer them as we go along. Okay, so what is Azure Cosmos DB? Azure Cosmos DB is essentially a managed database on the Azure platform. So what this means is that with Azure Cosmos DB, if you want to run a NoSQL database, you don't have to do anything else other than go on under the Azure portal, click a few buttons, and lo and behold, you have a managed a version of a NoSQL database up and running. You don't have to patch it. You don't have to worry about backing it up. You don't have to worry about HADR, all of that stuff. You don't have to worry about monitoring. All of that stuff is just done for you because it is a managed service. And it is globally available, right? It is. You can have a single Cosmos DB instance that is in fact globally distributed across multiple geographies. So the main characteristics that we believe is important for Azure Cosmos DB is, again, the global distribution. It's also a multi-model database. I'll describe in a moment what exactly I mean by multi-model, and it is a fully managed database service. The main characteristics that makes Azure Cosmos DB in particular shine is availability, right? There's a strong focus on making it available in terms of uptime as well as geographic distribution, including real-time replication. Performance, even in a globally distributed mode, we want to give you sub-millisecond data access characteristics. Okay, so that's another strong feature that is very difficult to achieve without something that is managed by a company like Microsoft on Azure. Scalability, so you can scale up or down as your data needs grow, up to multiple petabytes if that's something you need. And security, right? We also are focusing on making sure that these databases are as secure as possible, so that the customer data is as secure as possible. Now, the last point that I want to talk a little bit about is this concept of multimodal. Okay, so what do I mean by multimodal? Basically, Azure Cosmos DB is a sort of a chameleon, right? It can change its colors, it can change its nature depending on what it is that you actually need from it. And it can speak multiple languages, right? So one of the APIs that you can use to access is Cosmos DB is called the core API, and that is really nothing much more than a variant of SQL. In fact, Cosmos DB can behave as though it is PostgreSQL. So this is an interesting feature, right? It's basically merging the relational database with NoSQL database characteristics, the scalability characteristics and availability characteristics of Azure Cosmos DB. So you can use basically the same type of queries that you would issue against PostgreSQL, but it is going to be backed under the hood by Azure Cosmos DB. This is called Azure Cosmos DB for Postgres, right? It's a very interesting feature. The other API, that the one that I'll be actually working with in this particular talk, is MongoDB. So Azure Cosmos DB can behave as though it is MongoDB. So it is API compatible with MongoDB, and you're basically providing a document level document type database here. In if you're using the core API, it'll actually be relational. The API, that the behavior you'll see is that of a relational database. You can also Azure Cosmos DB can also speak Cassandra. Okay, so this is a column family type database. It's actually again one of the more popular NoSQL databases out there. So it can behave as though it is a column family database. It can behave as though it is a graph database using the Gremlin API. And finally, it can also support just key value types as well, right? So this is a strategy called Azure Table Storage. It's literally, okay, here's a key and then give me the corresponding value. So basically, Azure Cosmos DB is one NoSQL database that can support multiple different APIs, right? Multiple different APIs for various popular data storage mechanisms. Now, one thing that you have to be aware, you have to pick the type of database you want Cosmos DB to be like ahead of time, right? So when you are provisioning an instance of Azure Cosmos DB, you have to say, okay, this is how I'm going to store my data. I want it to behave like Cosmos DB, or I want it to behave like Postgres, or I want it to behave like Cassandra. And you cannot automatically shift from one type to the other. You literally have to go through a data porting exercise. The reason for this is depending on the type of data, the underlying storage is very, very, very vastly different to support the features of that particular database type. Okay. So enough talk. I want to now jump into the demo. Most of this talk is actually just going to be demo oriented. So the demo that I'm going to show you today actually is self-service. It's intended to be self-service. The entire demo is available on GitHub. It's on my personal repo. And basically everything that I will demo today, you can do by yourself. That's the intent of the of my repository. So I'll show you the repository real quick before we jump into the demo. So here's a repository. The URL is embedded in my slide deck. And the intent here is for you to get started with what I'm going to demo by yourself. Okay, so as you can see, there's some setup steps. Those setup steps I've already done. I've installed JDK 17. I've installed, I've used in this instructions, I say, let's use Eclipse, but in fact, for today's demo, I'll be using VS Code. Basically, you can use any IDE that understands Maven. If you wanted to use IntelliJ, you could use IntelliJ. That's no problem at all. For the demo, you will also need an Azure subscription. If you don't have one, don't worry. You can get one for free for about a year. Okay, so I do have an Azure subscription I'm going to use today. And you need this code, and I have this code downloaded in my file system. So the next thing you need for the demo is an instance of Azure Cosmos DB. And in this case, I'm using Azure Cosmos DB for MongoDB. So this takes a little bit of time to create, not too much time, but too much time for a real-time talk. Okay, so what I've done is I went ahead and created this ahead of time. So here is my resource group. Okay, so it's a resource group is really nothing much more than as the name implies, it's a grouping of resources. And in here, I have Azure, I'm sorry, this is the wrong resource group. This is the resource group I want. My apologies. And in here, there is Azure Cosmos DB for MongoDB instance. So if I click on that, okay, this is my Azure Cosmos DB for MongoDB instance. I can show you maybe the activity log. Okay, there should be some stuff in here, maybe. Okay, insights, perhaps. I can maybe show you some insights. Yeah. So I've been doing a little bit of playing around just to get ready for this demo so you can see a little bit of the activity going on. Okay. So there you have it. This will take you through an example of how to get Azure Cosmos DB from MongoDB up and running, which is step-by-step instructions. And next is the application. So the application is really nothing much more than some Java code. It is using Maven. And now I'm going to show. Now let's dive into quickly showing you what the application is doing. So I'm just going to run the application real quick. Okay. So the code itself, I'm going to show you through GitHub, but I'm going to do the demo real quick through VS Code. So first thing I'm going to do is just do a Maven clean. All right. So the Maven clean is done. And next, after that, what I'm going to do is do a Maven package. And really, the application is really nothing much more than a JUnit test, actually. So keeping it really, really simple. So let's go ahead and run the JUnit test. Okay, so success, right? I ran 6 tests. So let me show you some key output, and you'll see this output yourself. You can definitely run it by yourself. It's no problem at all. So first thing is I did a test persist. So I'm basically inserting some records into the database. Okay. Next thing I'm doing is so I've saved 3 different orders into my database. Next thing is I'll do a find. So first thing is I'm going to do a find by ID, right? So as you can see, I found my ID, and this is the order I found by ID, and the ID is 3 that I used. Then I can do more advanced querying, right? So as you can see, I found orders with a certain cost. I found orders for pinballs. Now, one of those. I found orders with a machine, 2 of those. Then I can do a quick test update. And here's my updated record that I'm printing out. Okay, and then finally, I'm going to do a remove, right? I'm testing the remove functionality, and I'm also going to test validity. So as you can see, I tried to insert a invalid order, and it will basically tell me, hey, you can't do that. I'm rejecting your invalid order because you haven't filled out some fields that are actually required, right? So this is the reason of why your request failed. So 6 different tests. I'm actually going to shut down VS Code now and begin to show you the actual code. And the easiest way to do that actually is to simply show you the code in GitHub. I think it's a nice readable format. So first thing is, let me show you the POM. It's a super simple POM. Let me increase the font just a tiny bit more. Just a little bit more. Yeah, I think that's good. You should be able to read it well enough. Maybe one more. Okay. So it's really quite simple. I'm using Java 17 here, as you can see, and really just using a couple of different very simple dependencies. One is the MongoDB API for NoSQL. So this is how I'm talking to MongoDB. I'm using the mapping API and the validation API, importing that, and then some other, frankly, helper APIs that are not terribly important. Then I have JUnit. I'm using JUnit 5 in this case, and I'm going to run the whole thing in Java SE. So I'm using CDI or Weld, okay, to run that. So there you have it. Now let's take a look at the actual unit test for a moment. All right, so I'm going to start there. So let's go to source, test, and here's my unit test. Okay, so let's take a look at the unit test real quick. So as you can see in the unit test, the first thing I'm doing is initializing the CDI container and getting an instance of a template. Okay, and the instance I'm getting specifically is a document template because I'm talking to MongoDB. I want a document template. Next, I'm just cleaning up the database. You can basically delete all records from here if you wanted to. This is what I'm doing. This is a test persist. Okay, so the test persist is relatively simple, just like you would in JPA. You're creating a customer. A customer is going to have an order. You can set the order's customer. You can set a description. I'm setting an address line, as you can see here. Okay. Setting a few order lines, and then finally doing an insert. So that's just doing an insert into the database. Inserting a couple of more records, as you can see here, and then finally making sure that, yes, I am indeed, I have inserted 3 records. The find by ID is relatively simple. It's simply template.find the type of object I'm looking for, which is an order, and then an order ID. And I'm then simply asserting that, yes, in fact, I found the order. Queries are interesting. So because I'm using MongoDB, I can more or less do queries that look very similar to what a relational database would do, because MongoDB understands the entire structure of the document. So I can say things like, for the order, get the total cost field and make sure that the total cost field is greater than 1,000. I can also say things like, get the order, look at the description field, and do a like query, again, with all strings that begin with the word pinball. I can even do nested field lookups as well. So I can say order, under orders, and order lines, look for a description, and within the description, make sure that the description matches the word machine. Okay, test update is very, very simple. You just do a find by, and then in this case, modify the record as you would want it, modify the entity as you would like it. So I'm just adding 2 different order lines here, and then simply asking the database to update it for me, and that's all. Remove is, as you can imagine, very, very simple as well. It's just simply delete, and then you can, if you don't specify an ID, you can delete the entire type of document, or you can specify an order ID. And then finally, here's the validity. So you'll see in a moment that the order object requires some fields, some required fields validated by the bean validation API. But I'm not doing anything. I'm just creating an empty order, and then I'm trying to insert that empty order. And as you saw in the execution, that fails. All right. So next thing we should take a look at is the main entity, which is the order object. So let's go take a look at that. So here's the order object. And by the way, Jakarta NoSQL does support records, Java 17 records, if you're curious about that. I don't have an example of that in the application, but you can use records if you wanted to. For example, address would probably be a pretty good candidate for a record. But in this case, all I'm really doing is using POJOs or just Java objects. So very similar to JPA, basically you annotate an entity with the @entity annotation. You can have multiple fields. So an ID, you can identify an ID field with the @ID annotation. You identify columns with the @column annotation, and here's the bean validation annotations. Right, so over here, I'm saying, hey, description should be not blank. The total cost should be positive or 0. There must be at least 1 order. Customer must be not null. So these are all those bean validation annotations. Other than that, it's just pretty much Java code, right? So you can have a list of order lines. You can have a customer and an address. And the rest of this is just plain old getters and setters. Not a whole lot to see there. Okay. So now let's take a look at some of the other objects that are in this object graph. So you can have embeddables, and again, this would be a good candidate for a record. So you have an embeddable with the @embeddable annotation, and inside of a document, what it will do is that it will create an embedded document within a document. instead of creating a separate document class itself by itself. So same deal here. You can specify a number of columns. You can specify bean validation annotations. Customer is very similar to that. It's yet another actually entity, a related entity. In this case, basically one-to-many relationship, and the same type of thing here. And then finally, there's the order line. And remember, you can have a list of order lines. So you can have a list of embeddable objects. Okay, and it's simply specifying a column with a line number and a description and a cost. All right. So that is about it in terms of the simple set of APIs that I wanted to show you. Last thing I want to show you is how do you configure this thing. So it's very, very simple. Actually, it's simply specify the type of database you want, right? The name of the database and a URL. So you can specify a connection string, and the connection string you can get from Azure. So very last thing I want to show you, and I think I'm running a little bit low on time, but it doesn't matter. Let's take a look at the database some of the data that we are actually playing around with here. So let me open up the database. Okay, and here's the order documents. Let me minimize some of that. And here's a rendition of our Java object, right? So you can see a JSON rendition of it. So there's the ID. Okay, @_ID represents an ID in MongoDB. There's a zip. There's the nested order lines. Okay, so you can see the nested order lines here. Okay, you can see the customer, the address. Okay, this is how the address line renders. Right, notice how it's an embeddable within my object, but it's simply a flat part of the JSON document. And this is yet another order object, and it is again represented in JSON. All right, so that is basically the very simple demo that I wanted to show you. What I showed you was the template API and the mapping API. If you didn't want to write the template API whatsoever, and you just wanted to use all of the queries, for example, just auto-generate it for you, you can do that using Jakarta data. Me personally, I think it's a bit overkill. For me, the template API is a good enough abstraction, and that's the one I tend to use. But if you wanted to, you can use Jakarta NoSQL with Jakarta data as well. All right, so that's about it in terms of the content that I wanted to share with you. I'll leave a little bit of time towards the very end for Q&A as well, in case you didn't ask any Q&A at this point. But to summarize, basically, Jakarta NoSQL is a standard for accessing non-relational databases. JNoSQL is its implementation, and it supports many different types of databases, as I've told you before, and it's a relatively nice, clean API as well. It's a clean room API. I think probably one of the better APIs for using NoSQL databases in a generic way. Cosmos DB essentially is a managed database on Azure. It is planet scale. And it's compatible with many different type of APIs. For example, in the demo I showed you that basically I'm using MongoDB, the MongoDB API. I could have frankly done the demo with Cassandra if I wanted to as well, just as easily with Gremlin. And you can use these technologies together in your cloud native or your enterprise applications very easily. And hopefully, the example code, the working example code that I gave you, and the demo that I gave you, and reproducible demo that I gave you should be a good, decent starting point for you to begin exploring these APIs yourself. A few resources I'll leave you with for today. So if you want to learn more about Cosmos DB, one of the best places to do that is actually the Cosmos DB docs themselves on docs.microsoft.com, and there's a URL for that. Or if you wanted to read more about Cosmos DB at a higher level, you can do that at azuremicrosoft.com. And there's a landing page for Azure Cosmos DB. The best place to learn Jakarta NoSQL is the spec itself. Okay, so I've given you a link to the spec document. And if you want to learn about the implementation, the only implementation so far, JNoSQL, the best place to learn about that is jnosql.org. And over there, you will see like examples of how to connect to the various databases, what JNoSQL databases are supported, and so on. So that's also a very important resource. So that's about it in terms of the presentation that I have. I'm going to just take a quick moment and share the links to my speaker deck account where this presentation resides. So let me go ahead and do that. Actually, I believe it's right in the GitHub URL. So let me just share the GitHub URL with you. Let me first get this down to 100% so I can navigate. Okay. All right. So here we have it. And I'll simply share the GitHub URL. All right, and there you have it. Last thing I'm going to do is, in case you have questions later and you don't have questions right at this moment, you can always contact me. Okay, contact me later. So I'm going to just leave my contact information. You can very easily contact me through my website. So I'm going to post that link for you as well. I'm going to stop sharing my screen. And we have, I think, about 3 minutes left. Okay, so if you have any burning last-minute questions, please ask them. Otherwise, you have yourself a good day. Thank you for having me. I hope this